What if the concrete under your feet could quietly fight the pollution above your head? In some cities, walls, roads, and buildings are being designed to act like silent air cleaners. The strange part is that the secret ingredient is not a machine. It is cement. Every day, traffic releases invisible gases that damage lungs, darken buildings, and trap cities inside a chemical cloud. Nitrogen oxides are especially dangerous because they help form smog and irritate the respiratory system. The cruel irony is that cities are covered with concrete, but most concrete only sits there. Engineers asked a simple question: could this dead surface become active? The answer began with a mineral already used in paints, sunscreen, ceramics, and coatings. Its name is titanium dioxide. Under light, this material can trigger a reaction called photocatalysis. It does not store pollution like a sponge. It helps break pollution apart. When sunlight hits titanium dioxide inside the cement, electrons become excited. Those excited electrons create highly reactive particles on the surface. These particles attack pollutants touching the concrete. Nitrogen oxides can be converted into less harmful nitrate compounds. Then rain can wash those residues away. The surface also stays cleaner because organic grime is broken down more easily. This is why the technology is often called self-cleaning concrete. One of the most famous examples is the Dives in Misericordia Church in Rome. Its bright concrete shells became a symbol of what active cement could do. The same idea can be used in paving stones, tunnel walls, noise barriers, and building facades. Roads are especially tempting because they sit exactly where vehicle pollution is born. A normal road carries cars. A photocatalytic road carries cars and fights their exhaust at the same time. Laboratory tests have shown impressive pollutant reduction under controlled light and airflow. Field results are more complicated because real cities are messy. Sunlight changes. Wind changes. Earth builds up. But the idea remains powerful because the material needs no plug, fan, or battery. It works passively wherever light and polluted air meet. The challenge is not simply adding titanium dioxide into cement. The particles must remain near the surface where light can reach them. If they are buried too deep, they become almost useless. Engineers also need strength, durability, cost control, and consistent performance. A city cannot rebuild itself with a material that cracks too early. So the real innovation is not magic cement. It is chemistry, architecture, and civil engineering working together. This technology is not a miracle cure for urban pollution. It cannot replace cleaner vehicles, better public transport, or stricter emissions control. It works best as a supporting tool. Its performance depends on light, humidity, airflow, surface cleanliness, and pollutant concentration. In shaded streets, the reaction can slow down. In dirty streets, dust can cover the active layer. And if cities use it as an excuse to keep polluting, the promise becomes dangerous. The true value of pollution-absorbing cement is psychological as much as technological. It changes the way we see infrastructure. A wall is no longer just a wall. A sidewalk is no longer just a sidewalk. A building's skin can become part of the city's environmental system. This is a new kind of urban design. Instead of adding machines everywhere, we make the city itself work harder. Imagine bus stops coated with photocatalytic panels. Imagine tunnels whose walls help reduce exhaust trapped inside. Imagine schools protected by cleaner surrounding surfaces. Imagine highway barriers that do more than block sound. None of this removes the need to cut emissions at the source, but it gives cities one more layer of defense. Air pollution is not only a local problem. It moves across neighborhoods, borders, and generations. The poorest communities often live closest to roads, ports, and industrial zones. That means cleaner materials could become a question of environmental justice. If public spaces can reduce even a fraction of harmful gases, the impact can multiply across millions of square meters. Small reactions can become large systems. The future of clean cities may not only be electric cars and solar roofs. It may also be hidden in the surfaces we stopped noticing. Ces curbs, ces valles, ces bridges, the road beneath every wheel. Pollution-absorbing cement does not make the city breathe like a forest, but it suggests something radical. The materials around us can become active participants in survival. The city does not have to be a passive victim of pollution. It can become part of the cleanup. And that brings us back to the first question. What if the ground under your feet has been waiting to become a machine? Maybe the next clean air technology will not look like technology at all.